Hello guys, you are welcome to another video. So today we are going to be looking at vectors. So what are vectors? So vectors are quantities that are represented by both magnitude and directions. So for instance, if I should draw a line like this, so this line, the arrowhead stands for the direction, while the length of this line stands for the magnitude of this. So this particular line is simply called a vector. So it has been represented in vector format. So an example of a quantity that is a vector is force. If I should apply a force on this block, so the force will move in a particular direction. So this direction is for this particular force here, for this particular block here is horizontal. So I can apply a force of, let's say, 10 Newton. So that is a vector. An example of a quantity that is not a vector is temperature. For instance, if I have 10 degrees C, so temperature does not move in a particular direction. So it cannot be categorized as a vector. Alright, let's look at the different types of vectors now. Let's start with parallel vectors. Parallel vectors, that is talking about the horizontal and the vertical. So let's say we have two vertical vectors. These are two vertical vectors. So they are not perfectly vertical, but they are vertical. Then we have two horizontal vectors also. So let's name them. Let's name this A. Let's name this B. So let's name this C. Let's call this D. Alright. So I can add up these two vectors. So these two vectors, they are in different directions. For vector C and vector D, they are both in the same direction. They are both parallel to each other, meaning they are both in the vertical direction. So we can call them J. They are heading the same direction. So to add up C plus D, to add up vector C plus vector D, C plus D will simply be, so let's give them number. Let's call this one 2J. Let's call this one 3J. So this is going to be 2J plus 3J, which is going to be equal to 5J. So that is it. So vectors that are in the same directions can be added up together. So because these are both in the same direction. So for the horizontal direction, we always use I to represent the horizontal direction. So let's call this one, let's call B, let's call it 3I, let's call A, let's call it 2I. If you're adding up A plus B, it's going to be equal to, that is 2I plus 3I, that is equal to 5J. So, but let's assume that we are adding up, we cannot add up A plus B, A plus C, because they are both in different directions. So that means we cannot add up 2I plus 3J. It's not going to give you 5 because these are not in the same direction. So before vectors can be added up together, they have to be in the same direction. Alright, so but they can be in the same direction, but they can be pointing in both the vertical direction but going the opposite way. This is what I mean by that. For instance, let's assume this vector C that was formerly going up, let's assume it starts coming down. So that means this C is going to be negative, but it's still in the J direction. So let's assume that for vector A that was going towards the right initially, let's assume that it's now going towards the left. So it's going to become minus A, and this 2 will be minus 2 for the horizontal. For the vertical, the 3J will be minus 3J, so that our C plus D will cease to be 5. So in this case now, C plus D will be minus C because it's going the opposite direction. Minus C plus D. So that's going to be minus 3J plus 2J, which is going to be minus j. So in the opposite direction. In this case here, this is going to be minus a for the horizontal direction plus b. That's going to be minus 2 plus 3i. That's going to be equal to 1j. So 1j. So that is it. Vectors that are going the same directions can be added up together. Alright, let's look at inclined vectors now. Let's say I have a vector that is inclined in this direction. That is this vector. Let's call this vector, let's call it AB. AB. So for this particular vector, it's going both in the horizontal direction and the vertical direction simultaneously. That is, it has x and y components. So I remember that our s is represented with I. So let's call this one, let's say this is 4i. So let's call this one 3j. So in order for us to get the magnitude of this, in order for us to get vector AB, vector is represented as in this format. You put an arrowhead at the top. So vector AB will simply be, for us to go from A to B, that means let's call this the meeting points here, let's call it O. So in order for us to go from A to B, we have to go from A to O, then from O, we go to B. So that simply means that our vector AB will be the addition of vector AO plus vector OB, which is equal to 4i plus 3j. That's going to be our vector AB. So this, you simply leave your answer the way it is because 4 cannot be added with 3. So vectors, this is the format in which most vectors are always represented. Vectors can also be in 3 dimensions, that is, on a 3 dimension for solid shapes. So we can have I, J, and K. So, but let me only focus on 2 directions for this class. Alright, so let's look at what we call the position vectors now. Position vectors. So let's say we are given 2 position vectors. Let's call this one x. Let's say we are given x as, let's say this is 5, 2. Then we have y. We are given y as, let's say this is 2. Okay, this should be more than 5. So let's call this one 7. 7, and so the x 7, the y, let's call the y, okay, let's call this one 3. So let's call this one 1. Alright, so this x and y stand for position vector. Remember that in coordinate geometry, we always represent coordinates in this format, that is 5, 3. So this simply means this is for x, this is for y. But in vector, we represent our position in matrix form. So this is called a matrix form. So if you are asked to get, for instance, we are asked to find vector xy. So in order for us to get vector xy, that means we have to connect an arrow that goes from x to y. That will give us vector xy. But what will be the size of this vector? We don't know. So in order for us to get vector xy, we have to find a reference point. In the case of this question, so our reference point is going to be at the origin of the graph. You can choose anywhere as your reference point, but it is easiest and it is convenient when your reference point is at the origin. So let's call the reference point O, so that we form 2 more vectors. So we call this one vector OX. Then we have the other vector OY in this direction. So that, but remember, what we are looking for is not any of these OY or OX. Our aim is to get vector XY, just using the position. So for us to do this now, remember how the last slide, we have to travel from X. We don't jump, we have to travel from X to O. Then from O, we go to Y. So that simply means that we are going to go the opposite direction of OX. That is, we are going to go minus OX. because we are going the opposite. So that's going to be minus OX plus OY. So this is simply going to be, that is OY minus OX will give us our vector. So what is OY? So that simply means OY is simply this coordinate that we are given. That is 7 OY vector. If you want to write OY in vector format, it's going to be equal to, this is going to be 7I plus 1J. If you want to write OX as in vector format, it's going to be, that's going to be 5I plus 3J. So, but you need not to. So that at the end of the day, for us to do this, we have to subtract this, we subtract this from this. That is, we are going to say 7, 1 minus 5 minus 3. And that will give us our vector. So this will now be equal to, so our vector xy vector xy will simply be will simply be 7 minus 5 will be 2, 1 minus 3 is minus 2. So, but remember that vector, this is not the way vector is represented. It's still in the position vector format. To write it as a vector now, so we simply write 2I minus 2J. So that will give us our vector xy. Alright. So that brings us to the end of this video.